Hi, welcome back to the last episode of this series program with C. In this episode, we are going to close down on the rest of the outlines we have structured and built in the beginning of this series. So first, we're going to be looking at struct overview and operations with pointers and functions. Then the concept of union in C programming language and its difference from struct. Then working with files as of creation, reading, writing, and finding of two different types, text and binary. Also, we're going to be looking at working with database connecting to specific type of database that is SQLite 3. Then finally, we're going to be looking at preprocessors and macros. Of course, we're going to be looking at some lab examples as we proceed in. So let's go ahead and discuss the first outline, that is data structure in C programming language. So basically in C programming language, a struct or structure is a collection of variables, can be of different types under a single name. You could look at it from Python perspective when we define a dictionary, so to speak. Let's look at the screen here, the first way of defining a structure in C programming language. First, we use the keyword struct, and then we indicate the name of this data type. That is called person. Now, within that person, we can open two curly brackets that include the different data types. So in this case, we have three different data types. The first is of type character. It's an array called name of size 50. And then we have city number of type integer, and then we have salary of type float. That's why you could see the first way we can create a variable, we call it person1 of type person. That is a struct in nature. Now let's look at the main function, how we are going to assign values to variables within that struct person1. Now you could see in the first line, we are using a struct pi function, which only expect a type of character array to assign whatever string to that variable. In this case, we are using person1.name, and then we assign this a string of a name, for example, Dennis Dahman. But when it comes to different type as of integer or float, we can just directly reach out to the name of the variable, like person1 dot city number, and then we assign the value. Now observe here the way we are assigning, we are using the dot operator. That's exactly the first way that we can assign value to a variable within a struct type. Then in the third line, we see person1 dot salary, and we assign whatever value of type float. Of course, after we do that, we could look at printing the struct variables is exactly the same thing. Depends on the type we want to print. In this case, we call printf name with a specifier string. By calling the variable person1, then we identify which variable within that struct, in this case, the name. That's why we print name is Dennis Dahman. In the second line of printf, the country code number of specifier digit. Again, we call variable person1, and which variable we are interested in to print, that's the city number. Same thing, go to the third type of variable, person1 dot the salary specifier f, that is a float. So this is the first way that we can actually deal or define a kind of a structure, and how we can actually reach out to the content within that structure. Let's look also to alternative way of defining a structure. In this case, we are gonna rely on a keyword type def. So here we create a struct, we call it person, and then whatever content of that structure, in this case, character of name array, then integer type, and then a float type. Then we assign this name called person. Later on, within the body of the program, we are going to use this person name to imply the type of data type person. That's why in the main function, you could see we define a variable called p1 of type person. And we know now person actually implies the struct person data type. Then the rest of the program exactly as we have done before, by calling the struct pi to assign to variable p1 in its variable name, the string of a name called the nice Dahmen. Then again, for P1 variable, we call the city number, we assign value of 9. Same for the salary of value of 25, and the printing function of the name, the city number, and the salary, as you could see printed on the right hand side of the screen. Now, last but not least, we could also actually contain a struct within another struct. So in this example here, we have a struct called complex that have two different variables of type integer and float. And then we create another struct called number. And that struct number contains two different types of variables. The first is a type of a struct that is complex that we define up there. We call it comp. And then we define another variable of type integer, and we call it integer. And then we can create a variable called num1 of type number struct. In the main function, if we want to start assignment, actually go with the routing tree, so to speak. So we have num1 dot comp is the first type, and the comp itself, it is a struct. That's why we call of the image variable first and then the real variable second. The same thing we could do for the second variable integer. However, this time is directly we can assign the value of 6 to integer from num1 variable. When it comes to printing, we just follow the same syntax by actually calling first the imaginary part of specifier digit by calling number1.comp.image. Same thing for real and then for integer. And you could see the result printed on the right hand side of the screen. Next thing we want to talk about is structure and pointers. Actually quite a bit important to understand and to start to appreciate the meaning of pointers. Now let's look at the example of defining a struct called person that contain two different variables, that is of type integer and float. First called age and salary. In the main function, we create two different variables. The first one is a pointer. We call it person pointer, and the second variable person1. Both of them of type or data type person, which is a struct. Now we call the person pointer to be assigned to the address of variable person1. So literally here we are creating a pointer of type person, as we have done in the previous episode by creating pointer of type integer or of type character. Same thing goes for this example. Now we prompt the user to enter a certain age, and here is the assignment. Instead of using person1 variable directly, we are using the pointer person pointer with using the ampersand, of course, since we are using scanf function. However, the only things I would like to draw your attention to here, the using of arrow operators. Previously we were using the dot operators to assign values. Here we are using arrow operators. So we use the arrow operators to assign the value to the age. And then in the second line, we again prompt the user to enter salary. And once again, we use the person pointer with the arrow operator to assign value to the salary. And of course, with the printf to display again the age and the salary, we use exactly the same thing, the arrow operators. Now you might wonder, and you should be able to understand the answer on your own, why is that so powerful? If later on, as we're going to see, we are going to pass a struct to a function or to any block within the code, we do not need actually to copy the entire struct, because a struct can be really large and huge, contain a lot of different type of variables. So in this case, can use that pointer to do any of the operation on that particular struct. So this is a very, very important way to understand about managing the memory and how your program can be really good and efficient if you understand the way how you could utilize the powerful meaning of pointers. Now next, actually we could also use the syntax of dynamic memory. As we have said, when your program is loaded, we cannot change the static size of the memory. That's why sometimes we need to locate a dynamic part of the memory using the heap. And that's exactly can be applied while we are creating a struct. Let's take an example here. We create a struct called person that have two different variables, age and name. One is of type integer, the other of type array. And then in the main function, literally, we are actually creating a pointer called PTR of type person, and another two variables n and I of type integer. So essentially, we prompt the user to enter a number of persons. For example, the user could enter 3%, 2%, 5, or 100, whatever number. And then we assign whatever value entered by the user to variable n. So basically here, we are going to start using the dynamic memory on the heap. We have discussed how to use the malloc. Previous episode illustrated different type of allocation in the dynamic memory. One of them was the using of malloc function, and malloc function has a certain syntax which we see in the screen here. First, we cast a type. In this case, we are going to cast on type struct person, and then we use the malloc function which expect arguments and whatever values entered by the user and the size of whatever kind of casting type variable. In this case, we are actually casting data type person, which is a struct in this case. Then I think the rest should be clear to you. We just use a for loop within the size of the n that entered by the user. So essentially, we prompt the user to enter a name and the age. Now I want to draw your attention to the following. Since we are defining a variable of pointer of data type person, in this case, to access members of the first struct person, what we use, the pointer with the arrow operators to the name and then pointer to the arrow operators to the age. How about the second person? In this case, we're going to use that pointer plus 1. So we have discussed on previous episode the meaning of addition here, plus 1 or minus 1. That means literally we are actually moving by block of the size of the pointer within the memory. So literally we are moving to the next block of the memory. That's why in the scanf function, of course, we are using a string type and a digit type. String will contain the name and digit will contain the age. And here we are actually calling on the pointer plus the I. In this case, going to be I from 0, 1, 2, whatever number that entered by the user. And then we use the arrow operators for the name and then the age. Now, if you go for displaying information, the same thing, we're going to use for loop and the exact same idea by using the pointer plus the I of the name and the age. And here is the example illustrated if the user entered number of person 2. So in the first line, we enter the name of the person, then the age. Same for the second line, name and the age, since there are 2 persons, and then we display the information. Now, the next subject is about the structures and functions. So let's look at actually how can we pass a struct to a function. So first we define a struct called a trainer that contains 2 variables, that is a name array and an integer type. And then we call in a prototype called a display function that expect an argument of data type trainer, that is a struct, and we assign a value called s to it for now. So then in the main function, what happens, we actually create s1 variable of data type trainer that is a struct, and then we prompt the user to enter a name, and we assign whatever value entered by the user to the name variable of variable 1, s1.name. However, I want to draw your attention to this particular part of the scanf. Now, we know what's a scanf, and the next important thing, we know why we are not using the ampersand as if assigning to integer or float, because we said with scanf, when we assign to a character, we do not need to use ampersand. But the point here, the specifier C, it implies the character, we know that. But what is this open bracket backslash of n? These open brackets implies the size that the scanf function is going to consider, and this size will be equal exactly to the size of the name character, which is of size 50 as we define up there. So the open bracket says the scanf expect 50 characters. Now sometimes you might enter more than 50 characters, but only scanf will scan the first 50 characters. It ignore any other character beyond the 50 size. And whenever there is a new line entered, then the scanf will consider the ending of the sentence. That's why I could write the name Dennis space DAHMAN'S, enter, and whatever the size of the index diamond, as long as it's less than 50, it will be considered as it is and then will be assigned to array name. Next, we could also prompt the user to enter the age, and here we are using the ampersand of s1.age, and then we call on the function display expect one argument of data type trainer, which is a struct, and that's exactly what we pass s1, which is of data type trainer, to display. And display function does nothing special but actually displaying information first, and then it calls on the s.the name and then the s.the age. That's exactly what you could see in the right hand side of the screen. So this is how we pass a struct to function in C programming language. We could also use function to return a struct. So in this case, we have a struct, we call it student, and it has two variables as usual, the name and the age. And here is the prototype of function called getInformation. And getInformation, basically, it returns a data type student. That's why in the main function, the first line, we define this variable called as of data type student, which is a struct type, and we assign whatever value to s using the getInformation. So if you go to the getInformation, basically it creates an s1 variable of data type student, which is a struct, prompt the user to enter name assigned to the name variable of s1, and same for the age, assign it to age variable of s1, and then return that s1. And once the s1 is returned, then it will be assigned to the s in the main function. And then the displaying information happens in the main function just as we done before by calling the s.name and then the s.age. And the information can be printed later as we see in the right hand side of the screen. So this is the second way you can deal between structure and function, by actually getting the function to return a data type of a struct. Also, we could do something else. Actually, we could pass a reference to the function. So in this case, we define here using the type def keyword, we create a struct called complex that have two variables, real and image of type float. And then we create name complex to imply the data type complex that is a struct. Now we see the prototype of a function called add numbers, which basically is a void function. However, it expected three different arguments. The first argument, or the first two arguments, actually two variables of data type complex. However, the third is just a reference of the same data type complex. We call it result. That's why we're using the asterisk to imply that pointer. Now in the main function, basically, we created three variables, C1, C2, and result of data type complex. In the first line, we just print or prompt the user to enter a first number, details of the real part, which we call C1.thereal, and we assign that using the ampersand. Same thing, we enter the imaginary part, that is image of the C1, and again we use the ampersand. Same thing, we prompt the user again to enter the second number, and then we enter the real part of it, assigning to C2 the real, and then we assign the imaginary part using C2.image. And finally, what we do actually, we take these two variables C1 and C2 in addition to the reference address of result, and we pass it to the add numbers. And the add numbers, you could see, we pass the expected argument. So basically it takes the result, and the result is just an address. That's why we are using the arrow operators, pointing to the real first, which is going to take whatever real part in the two variables of C1 and C2 and sum them together. And then for the image, again, we use result arrow operator for the image, and same thing we do to sum the two values of image for C1 and C2. Look at the right hand side of the screen, you see the result as expected. Now, the last thing to speak about when it comes to data structure, it's another type called unions. Basically, union is just a user-defined type similar to a struct in C, except for one key difference. Actually, structures allocate enough space to store all their members, whereas unions can only hold one member value at a time. Let me explain exactly what I mean. Say, imagine in this snap code in the screen you see, we have two different structs. The first of type union, we just use the same exact way we define a struct, but the key difference here, the keyword union, and call it union job that have three different variables. The first is a character name array of size 32, and then float salary, and then float work number. And we call the U job. That implies the union job. This is the first variable we define. And then we define a struct. We call struct jobs to make it different from the union job. And the exact same thing. Three variables of character array, size 32, and float salary, and integer work number. Now, if we want to print the actual size of both structs or variables, that is the uni job and the S job, what you could see on the screen is the size of the union happens to be 32, whereas the size of the struct happens to be 40. And why is that difference? Because the size of the union, you could see it just defined the size of the array that we already specified. We needed to create an array of size 32. So this is mandatory to be created when we initialize the program. However, it did not actually create any size in the memory for the salary or the worker number, because we just informed the compiler that we have two different variables. What we are not initializing any values for them, so it will be ignoring the size of that union. Just will be assigned the size that is implicitly declared, that is of size 32. Unlike the case of the struct, when we create these three variables, the character array and the float salary and the integer, actually the compiler make the assignment of this on the memory. So we have 32 plus 4, because float take 4 bytes on the memory, and 4 for the integer. That's why the size happens to be 40. 32 plus 4 plus 4. So this is the key difference when it comes to unions and struct. Now, which one to use? Well, it depends on. I could assume in some cases using of unions can be more efficient. However, you have to handle that quite a bit careful, unlike the case of a struct. But it left for you to make the decision as you make the design of your application. Now it's time to speak about input and output in C programming language. Basically, when we speak about input and output, that include some operations as creation, reading, writing, or seeking or searching within a document. So first, we're going to be covering the two different type text and binary content files. And then the third, for input and output, I found it appropriate to actually add the database part here. So let's first of all discuss the text and binary types of data files and how actually it happens in C programming language. Now, when working with files, we need to declare a pointer of type file. That's why in the first line here, we have this data type file, and we create that file pointer. Now, this declaration is needed for communication between the file and the program. Now, in the next line, we are going to deal with the opening of a file for declaration and editing purposes. So, opening a file is performed using the fopen function defined in the standard library header file. Now, the syntax for opening a file in a standard input-output is just by calling the f function. Within the bracket, expect two different arguments. First is the file that you want to open, I mean the complete path of the file, and something called the mod. We're going to discuss some of these mods in a while. And then we assign that to a variable. In this case, let's say PTR. Now, PTR will be actually the exact pointer to whatever file that we have pointed to and whatever mod we're going to deal with. And finally, important to see that we have to close the file after we have done whatever operation we are interested in. So before we actually take a comprehensive example, let's go ahead and see some of these mods that we are actually implying in the screen. Now here is the different type of mode that we can actually define while we are dealing with files in C programming language. The first mode called the R mode, and that is, as the name implies, reading. If this file does not exist, the fopen will return just null. It implies for text data files. If we have a binary data file, so we're going to use the RB. That's why we open for reading but binary mode, and if it is not, function will return null. Then we have the W mode, as the name implies, for writing. Now if the file exists, its content will be overwritten. If the file does not exist, it will be created. So this is the important things to realize using directly the W mode. Same thing for the WB, actually exactly the same, but however this works for only binary. The W only for text files. Then we have the A mode. A will be for text, AB for binary. Now here A is open for appending. So basically the data is added to the end of the file. Now if the file is not exist, it will be created. Next we have the R plus or RB plus, as we said, one for text, one for binary. It's basically to open for both reading and writing. So either you open to read or you open to write. Now if the file does not exist, the fopen will return null. This is very important to observe. If we have the W plus, which is exactly the same like reading and writing, however here, if the file does not exist, it will be created. And if the file exists, it will be overwritten on its content. Same for the A plus, it will open for both reading and appending. So if the file does not exist, it will be created. And if it exists, it will be just append to the end of the text. So these are the most popular type of mode that you need to be aware of. Now let's go ahead and explore a comprehensive example in code blocks about handling files with text or binary types in C programming language. Now here I have a complete example that shows you how to read and write and seek information within a file, either text or binary. Essentially, we're going to be looking at these four functions. The first one I call it write to a text or read from a text file. Then write to a binary or read from a binary file. And then we have the seek file that actually executing the task of search. But before that, as we have seen in the casting syntax, when we deal with file input output in C programming language, we need to imply the full path of the file. Now you could write that hard coding, the complete path, and you have to be careful, depends on the operating system. / when your operating system is Windows. However, only using the / when your operating system is just Linux or Mac. So these are quite a bit tricky things you have to find out your own way to understand. Now, unfortunately, to my knowledge, there is no such a function or built-in function can actually extract the path and do it for you. Unlike Python, the OS modules that offer you number of functions that actually done this job for you. To this end, I have decided first of all to create a function I call the assign full path, which actually does that exactly for me. So it goes and create this complete full path, which later on I'm going to pass to these functions to deal with. But this function is going to work as long as your operating system is Windows. If your operating system is Mac or Linux, then you have to make some adjustment to this function. So anyway, I will show you throughout the example. As you can see here, in the very beginning, we just create a struct. We call it a 3 number, just like a simple struct that have actually 3 variables of type integer, called n1, 2, and 3. So we have this 3 num data type. Now let's look first of all to these prototypes. Should be familiar now. The first prototype function called assign full path, then write text, read text, write binary, read binary, and seek files. All right, let's go to the main function now. In the main function here, first of all, I wanted to create this full path thing. So that's why what I'm doing here, I'm creating a file path pointer of type character, which is quite a bit obvious what I'm doing. However, the second line implies a file path of a character type array that of size 300. Now, this file path will be actually the complete path of the file that I intend to create, whatever for reading or writing of type binary or text. The next thing, I'm assigning this pointer to the address of this file path. So literally now this file path pointer will point to this file path. Now I can use this to point or as a reference to the file path by dealing in any function from now onward. Next thing, I wanted to make it within the main function is to assign the file name. In this case, this is the actual file name of size 20 character array. And I call it, for example, a program and .text. Later on, we can change this to .binary whatsoever. But for now, let's call it program.text. I am calling on the assign full path function now. This is the first prototype function you can see. Now, expected 3 different arguments. Expect a file name, which is this guy here, whatever file name you want. Expect the pointer for the file path pointer, like we passed here, and a size of the file path, in this case like 300 for example, so whatever the size. We'll see why I have decided to call on these 3 arguments. So let's go ahead and see what is this assign full path does for us. You could see in the assign full path, first of all, it call on a specific folder, or a specific string, which is a folder. Let me actually open the actual location of the current working directory where this application is working right now. Now I have this current working directory. You could see it. This is the full path where I have the file input and output. Now this is an empty folder and I am interested to create whatever file as a text or binary to be inside this particular folder. Now the current working directory of the project we have seen is this guy here. This is the current working directory up to lab 5. You could see first I have to extract this current working directory, and then after I do that, I'm gonna attach to it the actual directory file input output. So literally I will find the current working directory, then I will put backslash just like so, and I will put file underscore input underscore output, and then will be another slash to implies whatever files will be within that folder. So I hope the idea is quite clear to you. That's why first let's create this file input output location. So in this case here, I am using the double backslash as I said, before and after. Now if you are on Mac or on Linux, you should just use the slash directly. This double backslash before, because before that will be the current working directory, and then double backslash file input, double backslash, and this come my file name, which in this case, as we have implies here, for example, program.text. That's why here in the next line, I'm using the string concatenating function that expect 2 arguments. First is which folder you want me, or which string actually in this case, you want me to concatenate with. So if we concatenate this string to, which is actually containing this string, to the file name string, which we passed, in this case, program.text, concatenate them together. Now what I will have then, this folder name will looks like this: file input output backslash, then the file name here. Now I have this part become one complete string. I will take this one complete string and attach that to the current working directory. To find the current working directory, I could use the get current working directory from the standard library. Expect 2 arguments. First, expect the pointer, or where you want me to actually assign that to, the array in other way, and then the size. Now that's why we're passing the size of the array. In this case, actually, we want to assign that current working directory to this file path, which has a size of 300. And that's exactly what it's done here. Now, this pointer path to the file path with size 300 will contain the current working directory. Last step is just to actually concatenate both strings, the string we created now and the current working directory. Now, we'll return this assign full path after it's been executed. What happens now? This file path will literally contain the entire complete path. If you like, just like for illustration purpose, I can print F here to show you actually what that would look like. Now, if we print that, we could see the actual outcome exactly as expected. This is the entire full path. Now I have the full path of this program.text. So let's go ahead and continue the main for function we've been talking about. Let's first of all start with writing to a text file. So I already have prepared this function called write to a text file. Now what expect this function just pass to me the absolute path that we have just created. Let's go to this write text and see what is the syntax of it. As you can see, I'm using pointer here. I don't have to pass the exact string as it is, just only pointing to the address. I create a variable called num of type integer. We'll see why we're using that. But the point here, I'm using exactly as we said the syntax. First, I call this data type file. I'm creating a pointer called fPointer. Of course, here is the pointer of this data type. And next, I'm just following the exact same syntax as I have shown you earlier. I call the fopen, and now expect the full path for the file. Now, this full path already been created. And which mode I am using? Just W. It means writing mode. Now, just to check in case this file pointer, the file does not exist, null, that means the path has a problem. If the path is not there at all, I want you to print an error and exit. So this block just handling error block that we've discussed before. As I am done, it's fine. I found the path is correct. The file is in there. Now, if the file does not exist, which in this case is not. Now, if I open here, you could see that there is nothing in this folder. So literally this will return null. There is nothing. So what will happen? It will create that file for me, right? So that's why what happens here, say, well, enter whatever value you want. So enter a number, for example, in this case could be 5, 6, whatever number. And then I'm using scanf function, and I'm assigning whatever entered by the user to this variable that I have created first. Now num create whatever entered by the user. Now I want you to see how we're going to print or how we're going to write that particular entry by the user on that file. So here we use this function called fprintf. So actually it's very similar to printf, but here we have f in the very beginning. That means file printf function. So basically file printf function, it takes the pointer to whatever file that we created in the beginning, and we say, well, I want to print type of integer and the value of the num whatever. This is the syntax of using fprintf. And of course, we don't want to forget to close. Now, if we run this main function, of course, this write text is in there. Let's see what will happen now. One more time, so remind you, there is nothing in this folder, is empty here. Let's run this. And as expected, is actually prompting us to enter value. Now we are at this line. Enter a number. Let's say 25. As we enter, and we say we're done. Okay, and we could see now the text file has been created of type text. That is exactly the name we implied in the beginning here. That is program.text. If we open, we shall be able to read because it's of type text. Okay, but we're not going to read it actually directly from the window, but we will use another function called read text function. So that's exactly what we're going to do here. We're going to activate this function called read text function. Again, expect just the path of the file. So if we go to this read text function, what it does, once again, I will define here a variable of type integer. Again, I'm calling the data type file pointer, same exact details. And again, we're using the fopen. We declare this full path, but here the mode is going to be read only. Now, if that happens to be null, it means there is no file to be opened, something wrong with the path, then I just can handle that error and say, well, there's another opening file and exit. Otherwise, what I'm going to do, I will use the fscan here. Now, this is a scanf function what we deal usually with, but this time we're going to use the file scan function. So it's exactly the same like scan function, but this is for file. It has 3 different arguments. The first argument is the pointer of the file that we have created, and then what type of information we're going to write, in this case digit, and here is adding the address of the num. So basically whatever we are reading now from the file, now we are not taking from the user, but we are reading from the file. We assign the value that we're reading to the num variable that we created. As we are done, of course, we're going to call on printf function, go value of the n is equal to whatever assigned to num. And of course, we don't want to forget to close. So if we go and run this, we should be able actually to read exactly the value we have just entered, equal 25. Now, the exact same thing happens when we deal with a binary type, but the only difference here, instead of having text, in this case, we will have a bin type. So let's go ahead and see what is this write binary. It's exactly identical to the text one, with a small difference perhaps could be. Let's, in this case, we have writing binary, so we're passing the path. I'm defining here just a variable called n of type integer, and here we have a struct 3num. We call a variable of that type 3num. Okay, now num is just a struct. I wanted to like variate on the examples. Now here we have a variable pointer called fpointer of type file, and same thing, of course, we are opening the f path with the wb mut. Otherwise, what are you going to do? Actually, we're going to loop from value of 1 up to n less than 5. So literally, we're just making a simple loop in this case of 5 times, and every time we are actually adding a new value. So what happens here? We are taking whatever number that we have, and we are assigning to the struct of n1, n2, and n3. Just to remind you, in the very beginning when we defined this num, we said it has 3 different variables of n1, 2, and 3 of type integer. So here basically we are taking the value of the n. First we'll start with 1, and then the second value for the n2 will be whatever the value of 1 times 5. So in this case it will be 1 times 5, and then that n times 5 plus 1. So it's just like a small illustration showing that. And here what happens, I'm using the fwrite to actually assign whatever the exact value of the num, I mean the address, the size, using that struct number of 1 and the fprint. So this is the way we actually write when I have a binary type of file. Maybe this is the only difference from the text type when we were writing in the previous example. Of course, we don't want to finally close after we finish and we say just a simple message that the binary file is created. So one more time, show you in the current folder, we don't have this binary file. We just only have program.txt that we created earlier. So let's run this and see what happens. I will be encountered the binary file is created. That means in here. Now, if we get back, we could see that really the binary file is created. Now, if I attempt to open this, of course, I will be prompted what type of folder you're going to open because this is a binary file. Now, if you open this, you shouldn't be surprised that we'll have the values of zeros and ones because it's unreadable. This is a machine language now. So to this end, we are going to proceed by using the read binary file function. So if we go to the read type here, exactly as you expect, we pass the path, and then we create this integer just to hold the values and print them on the screen. And here we define the struct variable num of type 3num struct, and of course the pointer for the file type. And here just we are creating the RB, read in binary format. Of course, this is handling our part. Now, how to read? Same thing, so we loop in a 5, and here we are using the fread function. So in the previous one, fwrite, here we have the fread. These are only for binary. Now the syntax is exactly identical to the previous one with a small differentiation. Here we are reading, we are not writing. So again, we taking the address of the num, all right, and we take the size of the struct, and we're passing one by one. So literally we're passing line by line, and we assign that, or we done the operation on the f pointer, whatever is pointing to. And finally, let's print whatever values in here. So literally we will reach to n1 and n2 and n3 from this variable num that we defined earlier here, the struct. Okay, and then of course we don't want, after we finish reading, we're gonna close. Let's go ahead and run this, and as expect, exactly the values you could see. So in the first round we have like n1 and n2 and n3. We have 5 rounds, right? And in every round what we were doing, just adding 1, 5, 6, and then the 2, 10, 11. I hope the idea is quite clear to you what we have done in here. Last but not least, maybe it is appropriate also to speak about search or seeking in C programming language using the exact file variable data type. So here I have created a function called seek file. Again, this seek file will expect only to pass the pointer to the path. Once again, let's create just a variable called n of type integer and variable called num of type 3num, which is a struct, and pointer to the file. Again, handling the stuff, but here what I am reading binary type again, because just we have the binary. We could read also same exact details, could work also with the text, but I'm just using the binary in this case. So basically the idea is to call this fseek function. It's a file seek function that expects some of arguments. First, what is the pointer to the file? And here it goes with the two important parts. It called the size of the struct that you are actually dealing with up to the minus. It means it go backward by reading. And then the seek end. The seek end, actually, there are a few numbers. There's the seek end, the seek start, etc. These are the cursor. I mean, you keep moving line by line. So in this case, we are looping in size of 5, and we're just using the fRead function. And we have done before with the binary, right? And then actually we are printing. And after we have done that, what we're going to do actually in the fseek here, in this case, after we have actually read the file, we're going to use in a reverse order using the seek cursor, not the seek end. Let's actually run this and see what that would look like. So if you read the values of the n1 variable, it should be actually 1, 2, 3, 4, up, down, but now we read actually in a reverse order. So that was all about file handling with text and binaries in terms of creating or writing or seeking. Last but not least, how about dealing with databases? As I have said before, we're going to deal with SQLite 3. To connect to such database using C programming language, we're going to use an API. Now, first of all, we need to make sure that the SQLite 3 is installed. We have done that in the first environment setup in the first episode of this series. To confirm that, if you would have to go to your terminal, just write SQLite 3 and then check out the version of that, you should be able to see that because we have done the installation correctly in the first beginning of this episode. If you didn't, please check that out. I assume that SQLite is installed already on your PC. Now, in this case, I'm going to share with you the complete actually code with a comprehensive examples from the site that shows you actually how to connect to the database using the SQLite header files. That's what I said. If you have installed SQLite 3, and when you include that, you should have no problem at all and no error because this SQLite header file 3 should be included then and the compiler able to see that file. So basically here we connect to this API. So basically the connection or the standard operation of using this API is just well documented with a lot of examples. So here you create or you connect to the database, and then you start creating tables, and you can make inserting operation, of course. You can make selecting operations, update operations, and of course, finally, delete operations. So you can check these examples on your own and find out how to make the connection. It's very practical way. Sometimes instead of using files, you can rely really on such using of database like SQLite 3. It's a very, very good options and choice for a lightweight kind of task that you might intend to do. Otherwise, also there are so many interfaces to a larger kind of database like MySQL, maybe, and Oracles, etc. All right, last but not least, maybe it's time to talk about the last subject of operations and C programming language. In this operations, I'm going to just implies one important thing related to preprocessors and macros. Now, the C preprocessor is a macro preprocessor, which allow you to define macros that transforms your program before it is compiled. Now, this transformation can be the inclusion of header files or macro expansions. Now, let me show you here in the examples. First type, we call the including the header files. So basically we use this hash sample. Whenever there is a hash sample, this is called a preprocessor keyword, so to speak. So we use this hash sample we always use, and we use the keyword include. So in this case, we are using include for specific header files. So usually we have used the standard library, standard input, and some other header files that also come with C programming language actually installation. But that doesn't mean this only the header file is available. You can actually create your own header files, make it available for other people to use as well. The only things they have to do, just make sure that header files is installed in the right appropriate place where the compiler is going to see them, and then they could just in their script by using the hash symbol include and that file header name. Next type, actually, we can use something called the macros. We use the hash and then the keyword define. Let's look at this example here. We define pi as a macro. And this is how it's known. So here we have pi with 3.145. What does that mean? The compiler in any way throughout the application, if encounter with this word called pi, it will replace that with the value of 3.1415. So this is different from constant. Pi here is not a constant, but it is a macro. So think of it as a shell or placeholder. Also, you could define macros, could be a function as well. So here we define something called circle area, have one argument of r. The compiler encounter this particular sentence, circle area of r, it will replace completely that with the line pi multiplied by r, which is r squared. Actually, it's the area of a circle. So that's why we see here the pi is already defined, and then it will be replaced with 3.1415. And the r will be already passed when we use the circle area. So you could see in the main function, we define two variables, radius and area of type float, and then we prompt the user to enter a radius. Here we scan the value of the radius, we assign it to radius, and then here we call circle area and we pass radius value that entered by the user. Now this line, circle area, it will be replaced directly with 3.145 multiplied by whatever radius entered by the user. In this case, like say the user entered value 4. So it will be 3.1415 multiplied by 4 multiplied by 4. And this will be the area actually for that circle. So this is the idea we writing, or we can use a preprocessor and macros in C programming language. If you're also using Python as a kind of modules and packaging. So we have come to the end of this series. We have looked at the first episode, like how to set up the environment, have an overview on the language and the flow control, functions, arrays, pointers, strings, also structures and units we discussed today, file input and output, and some other topics and depth related to the technical setup of C programming language. One more time, I would like to remind you the purpose of this series was as a prerequisite preparing us for the second edition of the Big Bang of Data Science, and that is embedding systems. The aim for the second edition of the Big Bang of Data Science is actually to utilize the power of AI modules, embedding that kind of modules to work with physical machines. That is the subject of actually embedding system in general, or software engineering. And one of the prerequisites could be a very strong hold for you is to understand how to program with C. So in case you would like to actually program the microcontrollers by yourself, by the end of the series, you have a strong hold on understanding how to program with C and every aspect of it in general. The second prerequisite, I plan also to create a quick series that is related to the main idea over understanding on the concept of electronics. So we're going to have a comprehensive understanding of electronics in general, how they work, and what are the main components, preparing us also once we start the release of the official series of the second edition Big Bang of Data Science. These two prerequisites will give us a strong hold to proceed with our main aim, and that is how to utilize AI modules work with machines. Until then, stay well. Cheers.